Hello. Am I audible now? Can somebody confirm that? Am I audible? And really, I apologize for some of the technical glitches. I'm sorry for the delay. Actually, there was something wrong with the resetting the internet. I messed up some of the things. So that was. Can somebody confirm that? Am I audible? And is my screen visible to you all? Hello. Hello. Hey, can somebody confirm that? Am I audible? Hello. Still waiting for the reply, and then we can just start with today's topic. Hey there. Mm, hello. Okay, thank you. Thank you, Abhishek. Let us wait for 1 more minute and then we'll start. Wait 1 or 2 minutes and then we'll start. Meanwhile, happy Raksha Bandhan to you all. I guess some might have celebrated it yesterday and some of you might be celebrating it today, isn't it? So, just wait for a few more minutes and then we'll start. Meanwhile, I need some answers to my question. So what was the last thing that we studied tomorrow? What was it? What typecasting that we covered yesterday? I need a quick answer in the chat. Hmm. Anyone? I'm waiting for the answer. What typecasting did we cover yesterday? Hmm. No answers. Okay, so we studied about implicit typecasting that happens automatically. Okay, so yeah, we okay. So today we'll be learning about see today since it's a Rakhi and a Friday evening, so and basically the weekend starts today. Okay, so so let us start it quickly. So today we'll be learning about explicit typecasting. Okay. So let me just give you a flashback about the things that we studied yesterday, and then we'll go ahead with today's topic. Okay. So let me open my. Oh, it- let me open both so that we start with today's class. Sometimes this computer behaves very weird, and this software too. New window. I'm still waiting that it pops up with the new window and mm. Just hang on. Just keep some patience. Like I don't know why is it stuck. What's wrong with it? Acha, anyways, let it be. Let us open Jamboard. Jamboard. Jamboard is giving some trouble, so let's study Jamboard. Mhm. Let me open this one. Clear the frame. Okay. So yesterday we studied about something called as implicit typecasting. Implicit typecasting. And this was something that you don't have to worry about. It happens automatically. Why? Because in this, what we were trying to do is we were trying to store the data types which has got smaller size to the one into the one which were having the size greater than these of the previous one. Correct. So basically what we were trying to do yesterday was like we were trying to store if you imagine the data types as buckets, so and the data store into it as water. So this was my like byte, this was my short, and what we are trying to do is we are trying to transfer into the one which has got the greater size, correct, like int and long. So this is very quite evident that you can easily transfer all these things into this, isn't it? But today we will seeing a reverse scenario. Reverse scenario means today what we'll do is we'll try to store something from the larger bucket into the one into these all things into a smaller bucket. Okay, so this is called as explicit typecasting. Explicit typecasting. And forgive me for my handwriting. I'm not much habituated to write on a writing pad, so that's the thing. So today, let us say we have some integer data type, and what we are doing is we are trying to store it into a short or a byte. So what will happen, right? What you are trying to do is basically you are trying to transfer something that has got larger size, like, and we are trying to store into the one which has got smaller size. So, so imagine, just imagine a scenario of a bucket. You have a larger bucket and trying to transfer into a smaller bucket. So what is going to happen? Some of the water is going to spill off, isn't it? The same is true for the data types. If you try to store a larger data type into smaller data type, you are going to get some loss of information. You're going to lose some information. Okay. So there will be some loss of information, a loss of precision, and this is something that you have to explicitly perform. If you remember the previous case implicit, you don't have to do anything, just you have to assign the variables. But here you have to explicitly write. I'll show you an example how do we do it explicitly, but here the developer is responsible to do it. The compiler is not going to do it automatically. We'll see an example like how we are trying to do. Okay, so let me go to my notes frame now. So in the explicit typecasting, the programmer is responsible for for this typecasting. If you remember the previous one, here if we directly assign it, it used to work fine. Like we don't used to write what sort of thing are we going to assign into and the rest of the thing. But if we go to explicit typecasting, here the programmer is responsible. There the compiler was responsible. It used to take care of the things by its own. But here the developer or the programmer who is writing the program will perform it explicitly. Means you have to inform the compiler that right now I'm going to store a larger data type into a smaller one. Okay. Okay. So the second point says that this is also called as narrowing or downcasting. Narrowing means we are narrowing down the size, isn't it? What we are trying to do is we are just narrowing it. We are downcasting it from top, the one with the higher size into the lower size. Correct. And there may be a chance of loss of information in this typecasting. And this is very quite evident that if you try to store something of the greater size, so definitely it is going to contain more information. And when we will explicitly put it into something that is of a smaller size, we are going to lose something. And this is very sure. Okay. So I'll show you some of the example now, like how do we do it, some of the examples. Okay. So let us just comment out the things that we did yesterday. Okay. And let us see some of the example now. So I'll just simply comment it out, and let us do one thing. What we'll do is, so let me declare a variable as, first let me declare a variable as int. This is my int var, and let us store some value like 1250, correct? And let me declare another variable, byte, my, let me write my byte and byte var. Okay, we have declared it. Now what we'll do is we'll try to assign the one that we have declared above, the integer one. We'll try to assign it into a byte, and let us see that what goes wrong. Now let me just print the value of the byte, and let us see what happens. Okay, and let us observe the logs, like what exception does it throws, and again we'll backtrace it, like why is it behaving like this. So if you study the logs carefully, what does it say? Cannot convert from byte, cannot convert from int to byte. So the compiler is clearly throwing an exception that you cannot store something that is of greater size into this. Okay. So now if I want to do it, what I will do? Like, so this is not allowed automatically. Now you have to do like what need to be done. So what I'll do is I'll just put a byte here, which means that we are explicitly trying to convert this integer into a byte. Whatever value we are assigning is the integral value, and now we are trying to assign it into what sort of variable, that is byte. So you have to do the bracket that you see here is called as typecasting. So we are basically typecasting. What is this? My int var, this is basically an integer, and here we are putting byte here, to which explicitly states that we are trying to convert this integer into a byte, and this will be stored into this byte variable. Okay, now if I run it, this is going to work perfectly fine. Okay, now observe one more thing. You see the output, there is output is -30, not 1250. Why? Because if we there is a reason, solid reason behind it. I'll not get into that detail. So basically, what if you try to put it into like the binary, into the bitwise format, and if you remove all the digits, the integer is what? It's 16-bit. If you put all the values of 1250 into 16-bit, and byte, what will do? It is going to cover only the significant 8 bits. So definitely there will loss of some precision. So if you see the value here, that is -30, not 1250. So in explicit typecasting, we studied the points, like we lose information. So you can refer this example, that this is -30, which shows that we have lost some information. We were trying to store 1250, and finally what we are left is -30. So all this operation happens at bitwise level. So we are not, I'm not getting into the detail like how this data is calculated, but I can show you that we are going to lose some information. I'll give you some more examples. So now let us do is, let us define a variable called as double, and let us store the value of pi there. So what is the value of pi? 3.14, correct? Now what we will do is we'll try to store the value of this pi into integer value, and I will name it as int pi. And what I will do is I'll assign this pi to it. So you know that we cannot directly assign this double value to integer value, right? This double value has got size that is greater than that of integer. So we have to put here typecasting, right? So what are we typecasting it into? We are typecasting into an integer value. So I have just put int here. Now let me print both the values, the original pi value, and that is my pi, correct? And at the same time, side by side, I'll print the typecasted pi. And let us see the difference, like what is let me just comment out the one at the top, and let us see the logs, and you'll very soon realize, like, why do we when we do explicit typecasting, we are going to lose some information. So if you see the logs, the original pi value is 3.14, isn't it? But the typecasted pi is 3. We have lost the decimal precision, isn't it? So why we have got only 3 here? Because we in integer we are only interested in the whole number part. We are not interested in the double number part. So when you explicitly typecast this double pi into the integer pi, so you are going to lose the decimal precision values. So that is why you have got the integer pi as 3. So this is what it is called as explicit typecasting. So if you see here, we are developers and programmers who are explicitly putting this byte, int, and all these things here. Then only the value is assigned. If I remove it, you are going to get that the exception that we got back, that unresolved time compilation. Okay, so this is called as explicit typecasting. Okay, so let us just quickly again brush up the thing that we studied here. So what we studied, like explicit typecasting, is something that developers are responsible to do. Okay, so so explicit typecasting occurs when we try to put something that is of the bigger data type into the one which has got smaller data type. Smaller data type means one with the lower size. Okay, so basically what we do is we downcast it. Means downcasting means one with the higher precision data type, we put it into a one with the lower one. Okay, so and there is a chances of loss of information in this typecasting, and we also saw an example where we lost some of the decimal points. Okay, so if you see the last line here that is there in my notes, like whenever we are assigning a higher data type value to a lower data type value by explicit typecasting, the most significant digits will be lost. So try to, this is your homework, that try to perform some of these, whatever value you have, try to put it into a decimal in the bitwise format and check that. Okay, I'll share the notes. Don't worry. I'll share the notes. Don't worry about it. There's no need to ping me back on LinkedIn. Anyways, you can search me on LinkedIn. My name is Ashok. You can find me there. I shared the link on the very first day. Okay, Ashok Priyadarshi Floxus. You'll find me there. Okay. So now since we are done with the literals, now let us go learn about some of the basic operators. So what these operators are. So the first one, since we have studied about typecasting, we learn about now assignment. We have done with the assignment operators, the equal to operator from which we assign the value. We are done with typecasting. So let us learn about increment operator, like what this increment is. Okay, so this is the screen that you are saying, like y is equal to x plus plus or y is equal to plus plus x. This is a very common thing that you often see in your program, isn't it? And the one who are new buys to this world, programming world, they often find it very confusing. This when I was learning it, and actually I faced a lot of trouble in learning this. So I'll teach you about this. What is this pre-increment and post-increment thing? Okay. So let us learn about a new concept called as pre-increment and post-increment. So first, let us learn about post-increment. So you often encounter statements like y is equal to x plus plus, and here the x have some value. Like this is int x is equal to 5, and here is int y is equal to x plus plus. Correct. So now, as of now, forget this part. Just focus on this. Y is equal to x. So if you write y is equal to x, what will happen? Now the x is holding an integer value that is 5. And when we write y is equal to x, so what happens is this 5 is also transferred to this y. Correct? Y is equal to 5. Correct. So this is very clear. Now let us focus on this x plus plus part. So what does this plus plus mean? So this plus plus means that, first plus plus means that we are going to increase the value by 1. So make sure in mind that this x plus plus means, uh, just don't just don't focus on that where it is placed, before the variable or after the variable. Just focus on this plus plus means. Plus plus simply means we are going to increase the, let me write it here. Plus plus means increase the value by 1. Okay, so whatever value is assigned to this integer, its value is going to get increased by 1. Now comes the question of positioning, right? So I can write like this, x plus plus or plus plus x, correct? And we can assign it to any variable. So when you write it after the variable, this is called as post increment. And when you write it before the variable, it's called pre increment. Okay, so now let us understand the effects of this plus plus writing before the variable or after the variable. So what will happen if I'm going to write it after this variable x plus plus, and if I write it before, what is going to happen? Okay, so let us discuss the one in which we are going to write it before. So let me write again, int x is equal to 5, and then I'll write here, int y is equal to x plus plus. Okay, so let me just break this down. What actually this y is equal to x plus plus means? So this means that first you're going to assign this variable into y. Okay, the first step is we will assign x to y, x to y, which means that now the value of y is 5. So, and the second step is we will increase x by 1, which means after this end of the operation, what will be the value in x and what will be the value in y? So since we have written x plus plus, so it is going to assign the value of x to y first. So what will be y? Y will be 5. And after assigning, we are what? This is plus plus, which means the value of x is now increased to what? 6. Did you get that? I'll again repeat it. This post increment means that we are going to assign this particular value x first, and then we are going to increase the value of x. So this is what post increment means. Post increment means we are going to increase the value after assigning, correct? But if I change the scenario, what? If I change the scenario, if I write int x is equal to 5 and I write int y is equal to plus plus x, which means we are going to increase the value of x first, then we are going to assign. Which means at this point of time, first there will be increase in the value of x, which means what is now x? X is 5. Since we have write this pre-increment, this is before the variable, so it is going to increase the value of 5 to 6, and then it is going to assign this value to y. So now the value of y will also become 6. Okay, so did you get the difference? I'll just draw it step by step here in both the in both this scenario, like in the post increment and the pre increment, so that you can understand it well. This is post increment, pre increment. So the scenario is that we have already declared int x is equal to 5, and again we have declared here int x is equal to 5. And what we are trying to do here is y is equal to x plus plus, and what are we trying to do here is int y is equal to plus plus x. So in this scenario, what happens is first the value of x is assigned. So here what happens is the first y is equal to x, and then x is equal to x plus 1 happens. So these are the two steps that are followed. So what happens here is here the y becomes 5, and after this y becomes 5, the x becomes 6. Okay, but here what happens is here the step number 1 is x is equal to x plus 1. which means the x is increased first because this is a pre-increment. So what is the value of x here now? 6. And the second step is y is equal to x. So that is 6. So I guess this example makes very clear the difference between the pre-increment and post-increment. And you can find it a very detailed explanation in my notes. What is the difference between pre-increment and post-increment? And the same is true for pre-decrement and post-decrement. So decrement minus minus x means we are going to decrease the value by 1. Okay. Did you get that? Can get a thumbs up from the people who have understood it, and those who don't understood it can also ping me in the chat. So I'll again put some example for that. So can I get a thumbs up? I'm just waiting for the reply. Okay. Okay, cool. Okay, so chalo, let us go ahead. So let me show you. If you see the table here, okay, let me show this table to you. So if you see here, y is equal to plus plus x, and the initial value of x is 10 in each of the case. So if you see the value of y, okay, Giri has got some problem. Okay, Giri, just focus on this example once again. Okay, if you see the value of y plus plus x and y is equal to x plus plus. So this is what? Pre-increment. So in pre-increment, the value is increased first. So here what happens is the value of x, let me go to console and I'll show you with some of the example. Okay, so let me just comment out the rest of the thing. And okay, and then, so let me give you example. So let us, I have declared int x is equal to 5, correct? And now what I am going to do is int y is equal to plus plus x. And let me print both x and y. X is plus x plus y is plus y. And let me run this program. Now see the logs. Both x is 6 and y is 6. Why? Because you have increased the steps that we follow here is y is equal to plus plus x means, so y is equal to plus plus x means we increase x first by 1 and then we assign to y. Okay, now let me just change the scenario. Let us declare some variable here, k and j, k and I. K, k is I plus, let me write k plus plus and write k is and I is. Now see the logs, see the difference. Can you see the difference? The k is 6 but I is 5. Why? Because here we assign the value first and then we increase it. So what we basically do is we assign k and then we increase the then we assign the value to I first and then we increase k by 1. So this is the difference. Okay, so you can refer it again and again, the videos and the notes, you will soon understand this. So this is post increment, pre increment, and the same is true for decrement also. So let me go to the notes. Okay, so let me put another question to you. Okay, so so this will be a question for you all. So if I write, let us say, byte b is equal to, let us say, 12, and if I write b plus plus, okay, and if I write byte c is equal to 12, and if I write c is equal to c plus 1. So what's the difference between these two? Anyone can tell me what's the difference between these two? If I write byte b is equal to 12 and write b plus plus, and if I write byte c is equal to 12 and I write c is equal to c plus 1, what's the difference between these two? Anyone? If it doesn't know, you can tell that. I'll tell you that. Hmm. No, these two are not same, my dear friend. Okay, okay. So I'll tell you the answer. This b plus plus means, okay, okay. So what is the, acha, tell me what is the default data type for this one? This is int, correct? No, here what we are trying to do is b plus plus means we are writing b is equal to type of whatever the type of b is, that is byte, as of now. Type of b, data type of b, right? And this is b plus 1, correct? So in our case, this is actually hidden as byte, and here is the bracket, and we are putting b plus 1, right? But here, if you see here, we are getting a warning. Why? Because 1 is integer, correct? 1 is integer. This is not byte. And what we are trying to do? We are trying to add integer to byte, correct? So we have to explicitly typecast it to byte before addition. Then only this is going to work. Did you get that? So that was the fine line. That this is the very fine line. So if you write b plus plus, this is what compiler is going to do it by its own. But in the second case, what you are trying to do is you are trying to add a byte value and an integer value, correct? So here what we are trying to do was we are trying to add what? A byte value and an integer value, and we are trying to assign it into a byte value. So that was not possible, correct? I'll show you. Like if I remove this and if I try to print it, now it is going to throw me some exception. Like I'll just print C is, and I'll print C here. Just see the logs. You'll find the difference. See, cannot convert from int to byte, because when you add C and plus 1, so I'll tell you why this is happening. So what happens is when you perform any mathematical operator, right? So I'll put here max, and what is the type of C? The data type of C is byte. And what is the data type of 1? Int. And what is max of both those things? Int, correct? So this C plus 1 will return an integer value. And what you are trying to do? When you do C plus 1, so it returns you integer. And what is the data type of C? The data type of C is byte. So what you are trying to do? You are trying to put this integer into a byte value. And that is not permissible. Why? Because that is explicit typecasting. So if you do an explicit typecasting, you have to put it here. So whatever the result I have got, I will convert it into the one with the data type in which I'm going trying to store. And this will run perfectly fine. C is 13, correct? But in the above case, when you write b plus plus, So this is the operation that compiler does it by itself. This is implicit typecasting. Here the compiler is smart enough to understand that. But in the second case, that was explicit. Okay, so let me go back to the notes again. So see, this was the difference between those two. Now, if you do any mathematical operation on two different data types, the returned value is the of the type that is of the that have got the greater data type. So if you add byte and byte, you are going to int. Why? Because this is an addition operation and it is going to return int. Byte plus short will again return int. Byte plus int will return int. Char int. Char plus int int. So these are all operations. If you perform all these mathematical operations, this is not only true for plus, this is also true for minus. If you perform all these operations, mathematical operations, the one with the higher data type is going to get returned. So remember this in your mind. And I have means actually sought this example here. So whenever you will going to refer my notes, you will find this. Okay. So what's the difference between B plus plus and B plus 1? Okay. So that was just a thing. Okay. So since we have covered the assignment operator, okay, let us move to a bit about the flow control. So we are now done with the assignment. We have seen some of the basic increment and post increment. Now here comes the flow control part. So let us understand what is flow control. So I'll go to my editor. Now see the editor. See, there is a there are so many statements, then again statement, again a statement. So these flow control basically controls in which order these all operations are going to run. Like what logic I'm going to write there. So all these things are basically taken care by this flow control. So here we have like 5, 4, 9 and 2, 11 keywords that controls the flow of the program, the flow of the entire execution. So the first we have if else, then we have switch statement. These are for conditional things, like these all selective statements are for conditional. The second one is iterative statement. When we have to do something continuously, right? Like something that has to go on and has to get over at certain point of time. At all these point we use iterative statement. And the second one is for transfer statement. Like if I am to break through some this iterative statement or if else, or if I want to continue or I want to return something. So here we have all these keywords. Okay. So today we'll cover only about either I guess I'll be able to cover about if else, or let us say if time permits, I'll also cover switch. Okay. So let us start with the if else case. Okay. So if else thing is very common thing that we encounter in our life, correct? Let us imagine a scenario that it's a very fine weekend and what you did is you plan to watch a movie, correct? So you ask your mama for some money, correct? In our college, what we do, we ask for money from our parents. Like, this is the weekend, I want to watch some movie. So let us say we all want to see this rocketry movie that came, right? Nambi Narayanan, one of the Indian space scientists, one of the great Indian scientists. So this is a fine weekend and you want to watch this rocketry movie and you ask your mama for, let us say, 500 rupees for that weekend, correct? So what happens is that you bought the ticket for 300. Okay. So now you are left with 200 rupees. And the condition is that, let us say you want to eat something good. So you targeted that this is the dish that I want to eat. And you don't know the price, correct? You don't know the price. And there is some other thing that this is something for the fun element that is there you want to do. So after spending 300, you have this 200. So what you do? You write conditions. If this is going, if we are going to, if this is going to cost me 200, so I'll do this. If it is expensive than 200, so I'll do this, correct? So this is if else, right? If a condition here put, a condition will be there. If this particular condition, what is written here is true, so I'll perform something that is written here. Okay, let me clear the frame. Okay, so if else, in if else, what happens is, like if I put here if, and here what I write is the condition. What is the condition? If it is satisfied. So if it is satisfied means what should be its return type? Boolean, correct? True or false. So if whatever condition I write here is true, so the block just next to it is going to get executed. Whatever is it is written here. Else, else in case of if this is not true, this is going to happen. Correct. So this is the general syntax for it. If and else. There are other else if here, we'll deal with it. But as of now, just focus on if and else. If something written here is true, this particular block will be executed. If it is not true, this is going to get executed. I'll show you the example. Then the things will become more clear to you. So let me just comment out the things. Okay. So let me comment out this. Okay. So, no, voting is a very important thing in India. We are the largest democracy in the world. And as an Indian, we all are proud to be the part of the largest democracy in the world. So voting is a very important thing. And you know that what is the minimum age for voting? Min age for voting is? Min age for voting is 18, correct? And int my age. So let us say I am putting here that you are just in my age is 16, though I am not, but I will put here is if my age is greater than minimum age for voting. So I'll try to print some statement here. So this is something that is going to execute it like, है ना? What should I do? Welcome to polling booth. Correct. Else have some fun, kid. So now just let me run this and you'll see just observe the output. Okay. See what is there? What is the output? Have some fun, kid. Why? Because this statement got executed, not this, because your age is less than 18. So basically so what will happen is when you compare these two, if you see here my age, what is your my age? 16 and minimum age was 18. So if you compare these two, what my age 16 is less than 18. So what is this going to return? My age is 16 greater than 18? No, it is going to return false, correct? So what it has returned? False. So where it will go? It will get into else statement. If you see here, my age is what? 16. Minimum age for voting is 18. And what we are doing, we are using a greater than operator for 16 is greater than 18. So is it true? No, it's not true. It will return you false. 16 cannot be greater than 18. So since it is false, so the statement written in the else got ran. Okay, now let me just update my age to 26 and let us see what is the output. See, the output is welcome to polling booth. Why did we get that? Because your age 26 is greater than 18 and it has returned value as true. Okay. So here this thing is got compared. My age, minimum age for voting. Or you can, I'll show you one more thing, like bool res is equal to, let me just copy paste this entire thing here. Control X and I'll put this, this is Boolean. Huh? And if I put this result here, now if I run it, see the log. See the log. Welcome to the polling booth. So what we are trying to do here, when we compare these two, like this is greater than, less than, is going to return you true or false. Correct. So here this if statement accepts only true and false. Okay. If I try to put anything else here, it is going to give me some exception. See. If I run here anything else other than true and false, I'll get an exception. See, cannot convert from int to boolean. So this is mandatory that inside this if here, you have to pass the value that is boolean, either true or false. Then only this statement is going to get executed, else you can't do it. Okay. So this was about if and else. So basically and okay. And there is one more thing. So let us compare one more thing. There's something called as else if also. Else if. And I'll show you. So let us forget this as of now, my int age. So what we are trying to do is we are trying to categorize people based on their age. Okay. So if my age is less than 18, so what I will do is I'll print here, enjoy the chocolate kid. If else if your age is my age is greater than equal to 18 and or my age is less than equal to 60. Now let us say put it 59. Okay. I'll print here. Welcome to Gentlemen's Club. Gentlemen Club. Or else if you're aged, I'm going to write here. Go home, old man. Now see the things. So what it wrote here is welcome to Gentlemen Club. Why? I'll tell you what is the execution flow. First it checks if. Okay. If it is correct, it is going to run that. If it's not correct, you will get into the another else if, that either this is correct or not. So if it is correct, it is going to run this. Okay, I can write multiple else if here. Okay. If I want to put, I can write multiple else if with certain conditions. Okay. So I can populate some conditions here, then I can go on. So after checking if, it will check the another else if. In case all the else ifs fails to satisfy the condition, it is going to run the else statement. So this is the general flow of a if, else, and else if statement. Okay. So this was all about one of the conditional statement. So this was all from today. Let us quickly revise up the things that we studied today and we'll bind up the session. So let me go to the notes. So today we studied about, we started with explicit typecasting where we were trying to put the data types which has got greater size to 1 into the data types which has got less size. Okay. And we saw the consequences that we might lose some of the precision. And this has to be explicitly performed by the programmer, else our compiler will throw some exception. Okay. So this was the one thing that we studied. Next, we move on to the increment and decrement operators. Okay. So like how does this post increment, pre increment things work? There are other operators. It's your task to learn about the rest of the operators. I'll ask my moderator to put an assignment where he'll give you the notes about the rest of the operators that you have to study it by your own. So this was about post increment, pre increment thing that we studied, and do practice some of the questions on pre increment, post increment thing. I'll make sure that I put some assignment for the weekend so that you can go on with it. And the next thing that we studied about is like if I try to perform certain mathematical operators on the two different data types, the one with the maximum size of the data type is going to get returned. Okay, and how do we tackle it? And we studied the difference between what's the difference between if I write any data type and we just put plus plus operator, and what's the difference if we perform a basic mathematical plus operation on it. So we saw the difference. And then we started with the flow control, in which we studied about if else and its flow. From today and the next class will cover the rest of the thing like switch, while, do while, for. And in the further class we'll start with the other keywords. Okay. Those keywords will be primarily responsible for grasping your oops concept. Okay. So this is all from my part today. And can I get a thumbs up for today's class if you enjoyed it? Or okay. And meanwhile, happy Raksha Bandhan to you all, and happy weekend. My moderator will inform you in the group that whether there will be class on weekend or not. Meanwhile, enjoy your weekend, stay happy, keep coding. Okay. So I'll turn off the